So today we will be doing an assignment that is mostly problems from lesson 123, but we don't do the content at this school of what's in 123. It's geometric constructions and drawings and things. This content actually today goes back to lesson 30. If at some point you want to go back and read things in the book or look at some examples there for what we're talking about today. We're not going to go back and do the problems from lesson 30, unless we happen to have printed some of them on the problem set that I'll give you in a little bit. But as we were saying a few minutes ago, good practice for training your brain for making a logical case, particularly if you have any interest in being an attorney or doing something like that, where you need to present a logical argument to prove your case. A little bit of vocabulary that we're going to talk about first, but mostly we'll just jump into doing some of the logic problems. Syllogisms, this word over here, that's when we have a three-step argument to make a case. The first step is a major premise, and it's going to be something that either already is written in an if-then form, or we can change it to if this, then that. And then we accept that's true, whether it seems to really make sense on planet Earth or not. Maybe some of them are going to be kind of silly, and they might be things that make sense on some planet that we've never heard of in some galaxy far, far away that works totally different from ours, or some alternate universe. But whatever that major premise is, we'll say, okay, we're not going to argue that. We're going to accept that that's true. Now we have something else, which is a minor premise. And then we try to make a conclusion where we take that second statement, the minor premise, based on the major one. What kind of conclusion can we make? Sometimes we will use the word conditional for that major premise. We might call it the original conditional instead of major premise. It just means it's written if something, then something else. Now, what's important for you, some sentences aren't going to already actually have the words if and then in there. They're implied, but you will then be expected to write out the complete English sentence using if, something or other, comma, then something or other. We will expect you to actually write it in if-then form. So kind of repeating what I was saying up above, the major premise, sometimes called a general statement, that's the if-then. Minor one is going to be a specific case. And then we try to win our logical argument with a conclusion that fits with numbers 1 and 2. That will only work if number 2, the minor premise, matches the if part of number 1. And then the only conclusion for now that we can make is, therefore, something that matches the then part of the original statement that we're given. I know that sounds kind of crazy and a whole bunch of words there, but I think it'll start making sense and seem a lot simpler as we start looking at examples. So let's go on to the examples, and I'll come back at the end if anybody wants to continue copying this down. So here's our first example. Major premise. You would not have to write down that it's major. I'm just trying to tie this in with what we just said. If you are blue, then you are green. It's in the if-then form. Does that particularly make sense here on planet Earth? No. So we're going to say, okay, wherever we are, whatever universe we're in, this is the truth. Now the next thing we come across, Johnny's blue. So that's our minor one. Does it match the if part? The if's about being blue. Does this match? Is this also about being blue? But it's a specific case. Now we're talking about Johnny, not just anybody. So then our conclusion is, therefore, Johnny, our specific again, is green because that matches the then part. Does that one make sense of what we're doing? Not does the blue and green part make sense here on Earth, but does what we're doing with, we have an if then, we have something, does it match the if? Then we talk about that same specific one, but it has to match the then part. Any questions with that one? Now, let me also give you an abbreviation, because I know some of you hate to write, and therefore is kind of a long word. Therefore, in math, gets abbreviated by 3 dots that are arranged in the shape of the vertices of an equilateral triangle. So let's try another one. All birds can fly. Does that specifically say if and then in it? No, it's still our major premise, but we could rewrite it in if-then form. If it's a bird, or if a creature is a bird, if you are a bird, doesn't have to necessarily be exactly this wording, but it has to exactly mean this. Actually, write the word then. It can fly. Would that mean the same thing as that first sentence? Except that I put if and then in it. If it already has the if then, you don't have to rewrite it. But if it does not, yes, you are required in this course. Okay, then our minor one is Tweety cannot fly. Does that match the if part? So no, it does not. So it doesn't match the if. So we say for this course, no valid conclusion. Who knows what the word valid means? Bryce? Truthful, makes sense, one that works, one that follows the logic. Compared to invalid, maybe you've bought a ticket and it's to go in to see something, but it's not valid because it was for yesterday's show, not today's, or something like that. But it doesn't really work. Now, next year, you'll learn some other ways of proving points that may let you have valid conclusions on some that we don't have them for yet this year. But we're just going to deal with one kind of these this year. Okay, all even numbers are divisible by 2. Does that specifically say if and then? No. So Charlene, could you suggest how we might rewrite that with if and then? So they're talking about, you've got this first. So how could we write that with an if statement? Excellent. So if it's an even number, or somebody else might say if a number is even, then it's divisible by 2. Is everybody okay with one or the other of those as for rewriting the major premise in if-then form? Minor premise, 12 is an even number. Does that match the if part? See a bunch of heads nodding, yes. So it matches the if part. So that means we can make a conclusion about the 12, our specific number, that matches the then part. Who would like to suggest our valid conclusion? Grayson? So therefore, 12, our specific one, is divisible by 2. Now, that one's a little bit hard for us just to be thinking about because those two things are synonyms for us. Divisible by 2 is a synonym with being even. but we have to separate and take a step back and say we have to make it match the logic of the sentences in this case, because that's what we're practicing now. So all even numbers are divisible by 2. That's exactly the same major premise as I just had, right? So we still have, if a number is even, then it's divisible by 2. My number is divisible by 2. Give me a thumbs up if that matches the if part, and a thumbs down if it doesn't. Does my number is divisible by 2? Does divisible by 2 match the if part of that sentence? Not what do our brains think is the same. Okay, most thumbs are correctly down. Divisible by 2 is not what I have in the if part of the sentence when I wrote it out. That's why we're going to be writing them out in this course. This matches the then, not the if part. So we have to say, therefore, no valid conclusion. So it's just a matter of if and then. Does it match the if part or not? If it does, we write the valid conclusion that matches then. If it doesn't match the if part, we say no valid conclusion at this point in our study of logic. Questions from anybody?